Hello statistical friends, and welcome to another Chapter 9 video on statistics. Today I'm going to show you how to make a confidence interval using the calculator and do some calculations using it as well. You don't have to use the calculator, you can do this using your Minitab things or using the formula itself. So I'm going to show you how to do both. Should be fun. Alright, so read through the problem real quick. An experiment finds that 27% of 53 subjects report improving after using a new medicine. We're going to create a 95% confidence interval for the actual cure rate, and we're going to use these equals 1.96. Remember, that's the statistic that goes with 95%. Why is the interval so wide? Make it narrower with a 90% confidence. What are the advantages and disadvantages, and what sample size would we need to follow up study if we wanted a margin error of 5% with 98% confidence? So there's quite a bit of confidence levels going around here. I'm going to try to break this down and make it easy. So we're going to start by checking our hypotheses to make sure we can even do this. So, sorry about that. Let's start off with a plan. So again, we're starting out with the 95% confidence interval, and then we'll answer the rest of these questions as we go along. So we really want to see that in our sample, if the 27% subjects improved. Anyway, so we're trying to see what's going on for, anyone who uses the new medicine, not just the subjects that we looked at. So, plausible independence condition, probably good. The idea that one patient's improving from a medicine probably has nothing to do with whether or not another patient will respond, especially if they have no contact with each other. That's a little silly to think they'd be related. The random sampling condition. Patients were part of an experiment, so that probably means they were randomly assigned, hopefully. If not, this might have some problems, but we're going to assume it's true. The 10% condition, you shouldn't be worried about because this is medication, not patients, so it doesn't make sense to see if 10% of your population is taking it or not at all, actually. Success rate, this requires a little bit more. The success failure condition, our N times P, this is really hard to type, is 53 times, I should have used the pen, 0.27, because that's our success rate, which would give us 14 people, that's greater than 10. Let's check our failure rate, so that would be N times Q, which would give us 53 times the failure rate, which is the opposite of success, which is 0.73, which is found by doing 1 minus P, which gives us 39 people. And those are both bigger than 10, so we're good. All right, conditions checked. Let's proceed with figuring out our confidence interval. So since we know our N and we know our P, we're going to figure out our standard error, which I am going to have a really hard time typing. In case you forgot the standard error, you can go look at example 1. It's a square root of P times Q divided by N, which I found to be about 0.061. And so our margin of error, which is just Z times our standard error, is the 1.96 that we got for our Z times our standard error, which we just found to be 0.061. If you multiply those together, you should get a very narrow margin of error, which is 0.12. And then we're going to add and subtract that to our confidence interval. So to do our confidence interval, I'm going to take my P and add and subtract my margin of error, so 0.27 minus the margin of error, which is 0.12, to make our lower end, and then the upper end is the 0.27 plus the 0.12. So those are going to be our interval and how it's calculated. Oh, sorry about that. Which after you do that addition and subtraction, you get that that's going to be 0.15, comma, 0.39. So this is a very simple interval as you look at it. And I'm going to go ahead and do the exact same thing now, but on the calculator. So here's how you would do that. We're going to go ahead and turn it on first. If you need to see the video on how to download this guy, well, that's on our YouTubes. YouTube. Whoa. Okay, so I'm going to go ahead and hit the stat key. I'm going to arrow over to test, and I'm going to go down to Z interval, hit enter. Alright, so notice it has an option between data and stats. If you have a list of data in your stat menu, or in your lists, you can use that. We don't have data in our stats, so we're not using that. I 1. This interval is for testing for means. Oh, shoot. Hold on a second. I need the prop interval. Ay, ay, ay. There it is. 1 prop z interval. Good job, teacher. Let's hit enter. Okay, now it's asking for your number of successes, which we have that. We did that earlier. That's 14, which is another reason why you should do that ahead of time. I know my sample size to be 53. And then the C level, my confidence level, is 95%. I'm going to go ahead and go down to calculate and hit enter. Whee! Alrighty, and so you notice this is much more detailed than the answer I got by just rounding like the devil. So you might want to be a little more careful of this. So this is my 95% confidence interval, and then I'm going to copy this part, Control-C, hit enter, and now I'm going to do the 90% confidence interval to see what would happen. Da, 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 da. So I'm going to erase this first part since it's just plainly not true. Because I haven't done the 90 yet. So to do the 90, you'd first have to find the z-score that corresponds with 90%. If you didn't want to do that, we could go ahead and use the stat arrow, and then down to number 9. Oh no, not 9, 0. Yeah, A. Number A. 1 prop C test, and then change this to a 0.90 instead of 95, and hit calculate, and notice that gives you a much different interval. So 1.6 arrive to 0.367 7, yeah, 7, 6. So as you look at this, we want to be careful. The interval that we started with, the 95%er, was quite right for several reasons. The sample size doesn't really provide a great deal of accuracy in our estimate. It's not very large. And the standard error is actually quite large too in comparison to the original score. So as you look at this, the more confident we become in succeeding capturing the truth proportion, the less precise our interval becomes. So doing this 95% error, I mean, it's a little bit, it has some advantages, it's more precise, but we're definitely less confident in our ability to capture the true proportion with this interval. So this is going to require a little bit more work than, well, not more work, but it's not happening, yo. So if you want to see how to do the 90% confidence interval using other methods, you first have to come up with the correct z-score, which I did give you this z-score in your table, but the z that goes with this is actually 1.645, in case you were wondering. So the last thing I'm going to do is this last question, which is figuring out the margin of error of 5% with 98%. So the first thing we'd have to do is find the z-score that goes with 98%. So the difficult part about this is that I cannot draw on this computer. So I'm going to try to do my best to explain this. Ready? So I want the z-score that corresponds with the lower 5% of data. So how am I going to do that? Well, a couple different ways. I could look it up on the table, and why do I want the lower 5%? Well, if I want my confidence interval to be the middle 90%, or going 90% around, that leaves me with 10% left over, and since it must go on each side, you'll have 5% in each tail. Okay, so how am I going to find that? Well, on the calculator, I'm going to use the distributions. So I want to do an inverse normal, which is finding a z-score that goes with the probability. I'm going to select number 3. And then I just need to give it the area. So 0.0, oops. I'm going to put in another point there because I didn't hit the decimal point 5. My mean is 0, my standard deviation is 1. I'm going to hit paste, which is a little strange. Huh, never used this version before. This is very strange. Anyway, go ahead and hit enter, and that gives me the appropriate z-score. So this is my my z-star. That shouldn't have been a question mark. That should have been a z-star. Oh no, it's doing all kinds of fun things. Which I find to be, I just did this for 90%. Shoot, I need to do the 98% one. Poopily-doo, poopily-doo, poopily-doo. Okay, well, let's do 98% now. Alright, so if I want 98%, that leaves me with 2% left in the tails, which means that I need to find the Z star so that the Z is less than Z star. Gives me, oh, I need to enter this too. I always write the positive one since this is symmetric, in case you were wondering. So I have 2% left over, and then I divide that in half, and that gives me 1% because it's 2% on each side, not at the end, not on the left, not right, in the middle. So let's do that Z-score. So here's a little trick on the calculator. If I want to just shake this and change it to 0.01 instead of 0.05, I can actually hit second and then entry, and it'll bring up the last thing I did. You can actually do that several times to bring up like the last 10 things you've done. And I'm just going to arrow over and change this to a 2. All right, and then I'm going to hit enter again, and that will give me the Z-score, the Z star that I need. No, I want to stop to correspond with this margin of error that I'm looking for. So 2. Oh, I did 2. Darn it. Oy, oy, oy. Today is the day of error. Okay, well, entry. And I'll prove to you this will go back even further, so it goes back to 0.5. I needed that to be a 1, so arrow 1. I knew that was too big looking. Alright, 2, 3, 6, 2. Alright, now we're cooking with gas. So, if you remember, the margin of error looks like Z star times the standard error. Alright, and I know what Z star is now. It's 2.6 or 326. And the standard error is the square root. Shoot, this is going to be hard to write. I'm going to write caret. Most of you aren't going to know the root version of this, so I'm going to write squirt for square root. That'll work. Haha! The square root of p times q, and remember p is the, let's use curly braces for this so you know which is inside the square root and which one isn't. So that's the 0.27 times the 0.73, all divided by the sample size. Now the sample size is the thing we don't know. Okay, now that we've established this. The other thing is we know that we want the margin of error to be within 5%. So my margin of error must be smaller than 0.05. All right, so that's the start. Now I'm going to take this and we'll remove that middle junk I don't need. That was just us reminding ourselves what that formula looked like. All right, so the first thing I'm going to do is I'm going to divide by the 0.236 stuff, and then I'm going to square, and then I'm going to do some inverting and stuff and solving for things. This is a mess. Do your algebra. When you do your algebra, you should get that n is actually the 2.326 squared times 0.27 times 0.73, all divided by the 0.05 from the margin of error squared, which we're going to enter that into the calculator because you can. Ready? 2.36 326. No. I hit the wrong button. Squared. Alrighty, that's pretty. Times 0.27 times 0.73. All divided by, and here I'm going to use some parentheses so it knows to square this first. Oh, I hit the wrong braces. Just get rid of that. 0.05. And our parenthesis. No, I did it again. Ugh, I keep hitting the wrong buttons. No, that one. There we go. And then squared. Fun times. Actually, let's do square. This is a weird version of this. And then parenthesis. And then nothing. No, I want to delete that. You evil beast. Okay, there we go. Now let's hit enter. It's like 400 and 26 and stuff and things, and okay, I'm going overboard here. So here's the thing. You really can't have 0.546 of a person, so we are going to round this up. And we always round this up. We talked about why last time, so you really want to round this up to 427 people in your next experiment to be sure that your round of error will be plus or minus 5% with a 98% confidence. So that's how you can handle this and make it a little bit easier for next time. Hope you've all enjoyed this. Sorry it's so long.